So let us first read the statement of this problem. Find three numbers whose sum is 5 such that the product of the square of the first number, cube of the second number and the fourth power of the third number is maximum. So let us first make a mathematical formulation of this word problem. So we are solving it. So find three numbers. So we start with the let x, y, z be the three numbers. Now we are given that sum of these three numbers is 5. So we are given sum of the three numbers x plus y plus z is equals to 5, such that the product of the square of the first number, square of the first number, cube of the second number, y cube, and the fourth power of the third number is z and its fourth power. So product x squared y cube z raised to the power 4, and this product should be maximum. Now let us write this product as f. Okay. So our problems becomes we have to show that we have to find three numbers x, y, z such that the function f becomes maximum for that value of x, y, z, right? But x, y, z cannot take any arbitrary value. We should take x, y, z such that they satisfy the condition that x plus y plus z equals to 5. So it's a constraint problem where the function is x squared y cube z4, and this is the function that we have to maximize, right? And the constraint is x plus y plus z equals to 5. So the problem becomes we have to maximize function x squared y cube z4 such that x plus y plus z is equal to 5. Maximize function f equal to x squared y cube z4. This is our equation number 1, such that x plus y plus z equals to 5. So this one is our function, and the second one is the equation of constraint. Okay, let us form g function using this constraint. So our g function, g a function of x, y, z equals to x plus y plus z minus 5. Right? Now we will use Lagrange multiplier method. And what does Lagrange multiplier method says? It says at the points of maxima and minima, okay, f and g satisfy this equation. Gradient of f is equals to lambda times a gradient of g. And this equation is nothing but a bunch of three equations because we have three independent variables x, y, and z. So we will get partial derivative of f with respect to x equals to lambda partial derivative of g with respect to x, equation number 3. Partial derivative of f with respect to y equals to lambda partial derivative of g with respect to y, and partial derivative of f with respect to z is equal to lambda times partial derivative of z with respect g with respect to z. So equation number 5, and we have 4 unknowns: x variable, y variable, z variable, and the unknown parameter lambda. That's why we need 4 equations, and in Lagrange multiplier method the fourth equation comes from the constraint. So the fourth equation will be x plus y plus z is equals to 5. This is our equation number 6. So we will find the points of maxima and minima, that is x, y, z, by solving these 4 equations, equation number 3, 4, 5 and 6. and lambda as an unknown parameter will help us to find these points of maxima and minima x comma y comma z. Equation number 3, 4 and 5 we need partial derivatives. So partial derivatives of f with respect to x variable, y variable and z variable, we find it out here. So a partial derivative of f with respect to x, y and z will be treated as a constant. So this will be 2x y cube z raised to the power 4. Partial derivative of f with respect to y, x and z will be treated as a constant. So this is 3x squared y squared z4, and partial derivative of f with respect to z is equals to 4 times x squared y cube z cube. And again, partial derivative of g with respect to x is equals to 1. It's simple. With respect to y, again 1, and with respect to z, partial derivative of g with respect to z, again it is 1. So we plug in all these partial derivatives in equation number 3, 4 and 5. So 3 implies we get 2x y cube z4 is equals to lambda times 1. We have 3x squared y squared z4 is equals to lambda times 1. 3, 4 x squared y cube z cube, 4x squared y cube z cube is equals to lambda into 1. This is from equation number 5, and of course we have equation number 6 as the equation of constant. So what will be our next step? We will eliminate lambda between equation number 3, 4 and 5, and by doing this we will express y in terms of x, z in terms of x. We will put the values of y and z in equation number 6, and from there we will get the values of x followed by value of y and value of z, right? So we divide equation 3 by equation 4. So we're dividing equation 3 by equation 4. So we get 2x y cube z4 over 3x squared y squared z4 left hand side by left hand side equals to lambda over lambda. So lambda and lambda cancels out. So x cancels out one of the powers of x squared, y square cancels out 2 powers of y, and z4 and z4 cancelled out, and we remain with a 2y over 3x is equals to 1, and simplifying it for y we get y is equals to 3 over 2 multiplied by x. So we have obtained y in terms of x. Y is equal to 3 over 2 multiplied by x. Next we divide equation number 3 by equation number 5. We are dividing equation number 3 by equation number 5. So we have 2x y cube z4 whole over 4x squared y cube z cube is equals to lambda over lambda. Again 2 times 2 is 4, and we have x cancels out one of the powers of x, y cube and y cube are cancelled out, and we have z cube cancels out 3 powers of z raised to power 4. Lambda and lambda cancels out. So after this simplification in the numerator, we are left with the z only. So we have z over 2x is equals to 1, and simplifying it for z we get z is equals to 2x. So we have obtained y and z unknowns in terms of x. Next we'll put the values of y and z in equation number 6, and so next we put the value of y and z in equation number 6. So we have x plus 3 over 2x plus 2x is equals to 5. We further simplify it. So we have So further simplifying it, taking the LCM on the left hand side, we get 2x plus 3x plus 4x whole over 2 is equals to 5. 3 plus 2 plus 4 is 9. So we get 9x over 2 equals to 5. And after simplifying it, we get x is equals to 10 over 9. And putting the value of x equals 10 over 9 here, we get y equals to 3 over 2 multiplied by 10 over 9. And 2 fifths are 10, we get y as 15 by 9. And again putting x is equals to 10 by 9 in z. So we get z is equals to 2x, and this means z is 20 over 9. So our point of maxima and minima, is P point with coordinates 10 over 9 and 15 over 9 and 20 over 9. So the point at which the function f subjected to the constraint x plus y plus z is equal to 5 have a maxima or a minima is point P, whose coordinates are 10 over 9, 15 over 9 and 20 over 9, right? Now we already know that Lagrange multiplier method does not tell us about the nature of the point. Okay, it declares that okay, at this point it could be either a maxima or a minima, right? But it does not tell me exactly that this is actually the point of maxima or this is exactly the point of minima. So in our previous two examples, it was easy to find the nature of the points because we were having 2 points and we put one by one those points in the function. We obtained the function of values of the function at those 2 points. Now the point at which f had greater value, that was point of maxima, and at the point where the f has a smaller value, that was point of minima. Now in this problem we have obtained only one point at which the function either has a maxima or a minima. So then how to decide whether this is a point of maxima or a point of minima? Now let us suppose that this is point of maxima, right? So it means at this point f will have the maximum value. What does it mean? It means suppose there is some other point x, y, z which satisfies the equation of the constraint. It means at that point x, y, z, value of function will be always less than the value of function at this point of maxima, right? Because in a Lagrange method, the point of maxima is the maximum value is always absolute maximum value. It means function cannot have greater than the maximum value at any other points. On contrary, suppose this one is point of minima. It means at this point f is having absolute minima. It means at this point f will have the minimum value. So suppose there is any other point, say x, y, z, right? And at that point which satisfies the equation of the constraint, it's necessary that at that point value of f will be greater than the value of the function, greater than the minimum value of the function that we are obtaining at this point, right? So let us find nature of this point. Nature of this point P, 10 over 9, 15 over 9, 20th over 9, whether it's a point of maxima or minima. So first of all, let us find the value of a function at this point. So value of function at P is equals to x squared, that is 10 over 9 whole squared multiplied by 15 over 9 whole cubed, and 20th over 9 whole raised to the power 4. This comes out to be 10 raised to the power 2 multiplied by 15 raised to the power 3 multiplied by 20th raised to the power 4 whole over 9 raised to the power 3 plus 2 5 plus 4 9 raised to the power 9. Now let us take a random point that satisfies the equation of the constraint, and suppose this Q point is say 20 over 9 and 15 over 9 and 10 over 9. Now let us calculate the value of function at point Q, and this one will be 20th over 9 whole squared multiplied by 15 over 9 whole cube multiplied by 10 over 9 whole raised to the power 4, and this comes out to be 20 raised to the power 2 15 raised to the power 3 multiplied by 10 raised to the power 4 whole over this one is 9 raised to the power 9. Compare the value of f at p and f at q. You can see that the denominator is same. In the numerator we are having 10 raised to the power 2. Here we have 10 raised to the power 4, right? And if we have 20th raised to the power 4, we are having 20 raised to the power 2 only. So clearly the value of function at point P is greater than value of function at a random point Q, right? Now as we have declared earlier, at point P either the function has a maxima or a minima, right? Now it can't have a minima, because if had it been a point of minima, this fp value would have been the least value of the function. It means it should have been less than any other value of the function at any other point on the constraint, right? So that's why we say that this is point of maxima, okay? And the maximum value is given by this. So we have f has a maxima at point P with coordinates 10 over 9, 15 over 9 and 20 over 9, right? And what was the question? Find three numbers whose sum is 5 such that the product of the square, okay? So the three numbers which satisfy the conditions given in the problem are, the three numbers are x is 10 over 9, y is equals to 15 by 9 and z equals to 20 over 9. Thank you.